Hello, welcome back to Blender Sushi live noding. So in the previous live noding, I talked about Blender cycles and how you can use this math function greater than in order to create this kind of render that looks quite interesting. It's almost like a kind of like a cheese. It's a volumetric noise, volumetric 3D noise that's kind of visualized, and it's become almost like physical. I'm gonna try to do this, the same thing, using SphereChalk add-on. And with SphereChalk, it's all about working with mesh data. So let's see if we can do this properly. So let's save it as SV greater than. We know that at some point we actually, I was exploring this marching cube algorithm and kind of able to create a 3D mesh based on kind of a volumetric abstract data. And I'm trying to do that using cycles and SphereChalk. I tried, but let's do the basic one first. So let's start with I'm gonna start with a real objects in the scene. It's a cube, and I'm gonna subdivide it multiple of time. Instead of using the Catmull-Clark, let's go switch to simple. With simple, if I turn on the wire, you can see that's the detail. So I'll increase it until around here. So 5 subdivisions. And from here, I'm gonna switch to SphereChalk. And let's see, I'm gonna use objects in, get the selections, turn on pause modifier. So it's gonna give us the mesh that's exactly looking something like this. And let's use noise. So vector noise, I think that should do. And I would like to actually to visualize this as well. So the best way, the easiest way, switch to cycles and use vector noise. So get all the vertices, get the output, plug it into vertex color. Vertex color. Yep. And pipe in our objects. And this color of the noise, I'm gonna switch to scalar. So we have like a single value instead of vector. And plug this into the color. Hopefully we get something. So with this guy being selected, I'm gonna switch to cycles, give it a shader, and let's check. We have SV call for vertex color, so I'm gonna do that. Attribute SV call, plug this into the color. Hopefully we can see something. So still can't see anything. Let's plug this into emission color. Okay, we can see some kind of a value there. Somehow it's in color, so you can see a value. Let's switch back to SphereChalk and let's check it out. I might have done this the wrong way. Double check. This one should be RGB. Clear unindexed. Okay, what is that? I think this should be correct. So it's like a noise. So you can see there's some kind of grayscale value. So definitely it should be RGB and then scalar. And I just need to increase the contrast. Let's here use the greater than math and use this. Oh, we don't have greater than under the math, so we need to use comparison. Logic functions. There you go. Greater than or equal. Let's use this guy. So this is the noise value, and it should be I think it's in Sverchok, the noise value is not between 0 and 1. It's actually between -1 and 1. So we need to be careful there. But the idea is to be able to kind of tell whether we have value that's greater than 0 or actually greater than a value or lower than a value. So here it's kind of already happening. I probably need to remap the noise. So like I said, maybe try remapping this guy into the value that we can monitor. So I think it should be correct. Something like that. It's a little bit trickier, but than I thought. Let's say if we use vector math, try scaling the noise. Maybe I shouldn't do this right here. Let's try to get something first. So there's clearly some kind of noise value, but it's not particularly interesting. Let's try doing it differently. Let's use a mask vertices and bring all the data from there, and then try using the output of this vector noise as a mask. And a mask, of course, is expecting 0 or 1 or true or false. And as a result, we should have an output here. And let's just put that to the side. And let's see if we can generate something that's interesting using this guy right here, greater than. So, all right. Now it starts to get a little bit more interesting. That's funny because the noise, we can't see the result here, but we can see the noise actually kind of eating out the polygon face. So let me increase the value there. Maybe I did something wrong here with the color. Oh well, so we don't need to see the color for now. I'm gonna ignore the color, but you can see the result here on these objects. So based on our cube being subdivided, and we bring it into Sverchok, and we are masking the vertices using the noise, you can get something that looks similar to our kind of like a cheese pattern here. The nice thing about this, of course, this is actually 3D volumetric, and there's things like stray vertices there that I could clean up, but we can, at any time in point, we can go back to this guy, increase the subdivision, or maybe like triangulate it. If I triangulate, you can see this this noise gonna be a little bit cleaner. And then also, if I'm using like Solidify, I'm gonna get a more interesting result. Let me try doing that. Turning off the point and the edges, and let's see if I'm using an empty there. I'm gonna scale it a little bit. Select this guy, and I will use an array modifier. Turn off this relative offset. Use the object offset instead, and use the empty. Try repeating that a couple of times and look at the wireframe. You should see we have multiple array duplication of these objects, and it's gonna be high detail. If I update the sphere chalk setup right here, you can see this guy is now generating something that looks like a volumetric. It's almost like you can render it out, almost. Because this guy is actually real objects. So let me try selecting the empty and scale this differently, just a little bit. Scale it down. Go back to this guy and then increase the array modifier, maybe 20 times, or 25. Let's see, it's quite a lot. Maybe I shouldn't go too far, maybe just 10 or 15, and then update the whole setup. So sphere chalk add-on will take care of the objects inside, and then it's gonna apply all these mask vertices on each and every polygon surface in here. So let me try baking that out. So this guy, if I put it to the side and then enable ambient occlusions and madcap, you can see how the noise is eating out our mesh. Maybe I should try like keep doing this, getting smaller and smaller until you can't see the cube, until it's small size, and see how it's layering our mesh. That's actually kind of interesting. This is almost like the marching cube algorithm, but we are doing it more procedurally. I guess it's easier to understand this way. So now I just make it like 10 times the amount, and it might crash Blender. I don't know. It might actually take a while. So maybe I should stop right here, but you can see the idea. We are using 3D noise and greater than math functions to create some kind of mask. And based on that mask, which is basically true or false, whatever it's false, it's gonna eat our mesh either way or another. So if we try doing this a couple of times, you can actually get a quite interesting result, I believe. So it's already done. Let me try baking this out. So this guy will come as a single surface object. It's quite high. Imagine if I'm actually rendering this out. Let me save it first. So it's 150 layer, 150 slices in all 6 directions of cube. Let me try duplicating that thing again and then subdivide. Kind of wondering if I could actually remesh this guy, you know, solidify and remesh might give us an interesting result. So solidify, we'll turn it into a 3D object, and then we use remesh. It might complain, but try smoothing it out. So now you can see some kind of 3D object, almost like something that's ready to be 3D printed. It's very strange because it looks like an ant, kind of something that ants will build, or like a honeybees. So there you go. That's being remeshed on the fly. So I think I need to continue experimenting with this idea. Maybe it's not exactly perfect with the noise, but it's interesting. From a cube, you make a multiple array of layers, and then you eat those mesh using the noise, and then you remesh it back. So yeah, maybe this is something that I could print. It's interesting. It's I don't know. Imagine if you go inside it and then start to I don't know, make a game based on this. Anyway, that's the whole idea. Of course, I would like to be able to connect cycles, material, whatever I created using cycles into SphereTalk. I don't know if that's even possible, because with cycles, it's you are creating really like abstract looking data. That's not something that's easily transferable into 3D mesh, I guess. Um, if you think of it like a volume, how do you render a smoke, for example? How do you 3D print a smoke? It's not possible, right? Unless you freeze the smoke and turn it into like a solid object. But anyhow, that's a interesting topic, I guess. So yeah, thanks again for tuning in on this. So the idea is really just using this greater than functions to get something out of it. You can try other functions. We will see. But for now, 3D noise and this greater than functions will generate something quite interesting. So there you go. Thanks again for tuning in, and I'll see you next time. Bye.